Okay, so hello everyone. The talk is about Canary monitoring, and yeah. So first, maybe the question: how many of you will consider yourself as a Java developer? Can you please raise a hand? Okay, and then, no matter what you think is the DevOps. Okay, and SRE, maybe. Yeah, so we have also two SRE. So I will have a small question to you later at that. So, like, just to tell a little bit what is SRE, and at the same time, like who I am. So for me, SRE is a triathlon in IT world. So we need to combine multiple disciplines. So I picked that development. I was a Java developer as well. Will be riding a bike, pleasant experience. You visit lots of places. You see lots of things. Then DevOps will be like running, a little bit more challenging, especially after doing a bike. And then for me, I don't like swimming that much, so the role which you might be surprised as a role of like product owner or a product manager is also, or project manager is also a part of SRE. And surprisingly, for many, it's the hardest. So as SRE, there's usually nobody who will tell you like what you should do. It's just that you need to know it. So you combine all of those three things, and you don't combine it day after day. You combine it at the same day, at the same time, usually, which is making the triathlon and SRE a little bit more challenging for all of you. And to be like a little bit more into the kind of what is the mindset of SRE, I asked my colleagues on the conference, and this is what we get from Mentimeter. So you can see here like it's a mindset, it's a lot of things, firefighting for somebody. So it's really interesting to be that. But SRE is one topic, I can spend some time on that, but the presentation is about the Canary monitoring. Yeah? So that's a canary bird that you're familiar with, and the reason behind canary monitoring is called like that is that canary birds were used by the miners in the mine to detect the poison gas. And they were taking a cage with the canary bird with them, and as soon as they realized there's a problem, the canary was faster than any instrument, and at that time there was not many instruments to detect the poison gas. So that's basically what we want to do in the world of IT in the same kind of manner as the miners. Yeah? So they didn't care what was exactly poison gas. They just cared that it was there and their life was threatened. So that's the same what we want to achieve with Canary monitoring about our systems. And I will explain it later, so you will see also the details. To start with and have it done, it's what I want to give you as the what is the Canary monitoring. Yes, so I will talk it in the details all of that, but just I want that you have it the same and we know what to expect. Is that from me, and I would say it's the ultimate tool to do a monitoring, to start monitoring. It gives you the ground truth. It gives you a lot of advantages that you will not get anywhere else. And this is the tool that is the best value for money or effort that you can put into. And I will try to all explain in the details so you will have the same basically understanding at the end of the talk as I have. So that's really a talk that we will start from the basics and go through it later. So I want to emphasize on the very important part of the Canary monitoring. So it's detecting what is basically your threat model. So what is the use case that you want to use as a monitor? Yes, so it cannot be just pick my HTTP server. It has to be a use case that the customer is really using that. Yes, so I picked the e-commerce website. It's not maybe the best for Canary monitoring and not the best for what we do on a day-by-day basis, but it's the best that everyone uses it and knows how the e-commerce website should work. Yes. And the first thing that you need to raise is that the use case is a step-by-step process. And then when you consider a use case for the Canary monitoring, you need to think about basically the situation when your boss calls you that the system is not working. It will not be middle of the night, but it will be angry boss. Yes. So the first thing, and like Amazon will or any e-commerce website, when the first page, like the starting page, is not loading properly, that for sure the boss will be angry on you. Yes. So that's the mindset that you should have. But it is not enough for the e-commerce website that only the first page is working. Yes. So what they will do, yes, they will go browse some categories, for example, or use search. So that's like the journey that you have to follow yourself and think about it, like what are the important, really the most important points of the system that your customer visits. Yes. So of course, when there's a good customer, they will try to buy the book on your site, which is the site reliability workbook. So that's the thing that you want to monitor, that it is there. Yes. And then you need to think about it still not through your application point of view. You need to think about it from the customer point of view. And the customer will not buy the book by HTTP call to the service that you expose. He will click a button. Yes? So that's the first problem that I can see on this path, that how we really be sure that in the use case of the buying the book, the buy button is working. Yes, with JavaScript. Yes, your boss, when he will call you, that the customers cannot buy books, he will not be happy to get explanation that HTTP service is working, and that's the JavaScript problem on the page. Yes, so that is very important that you follow the customer path, not try to think about the system point of view, but follow the customer path quite realistically, or as much as realistically as you can. And then it does not stop when you add something to the cart. It goes further. Yes, so of course that is important, but you need to place an order. Yes, so that's the moment that the basic use case is finished, is the moment that customer confirm the checkout. So also the whole checkout process needs to be in the, let's say, when I will be monitoring with Canary the e-commerce website, the whole process of the purchase up to the moment that the order is placed on your site. Yes, so that is basically the end, yes, of the first use case. And you can argue, but I think most of us will have the same understanding of the e-commerce site, that this is the most important one. So that is the first thing. The second thing that you can see here is that when I will be placing the order, and it's Canary monitoring, so it will be repeated task, I will most probably quite quickly use the whole stock of site reliability engineer books in the shop. Yes, so and then maybe boss will not come to me because the page will be monitored quite well, but the guys who process the orders will come and say, okay, you make 1,000 orders in the past 1 week, and we basically are stuck with the site reliability book, and we cannot send them to nowhere. So the question will be how you clean this stuff up. Yes, so that's the challenge that you need to solve, but still the use case must be complete. You can do some tricks in that. Like with the e-commerce site, you can just cancel your order just immediately when you've done it, yes, and make sure. It depends how well you are within the company and can communicate. So you can place an order, then just say monitoring in the name, for example, and they will not try to process it if they will find it, or they will know where to go. If you put SRE monitoring stuff, they will know that you need to be contacted, and so on. But that is challenge to solve how to do that. And as with all end-to-end test or Canary test or heavy test, you need to be careful what you pick to basically cover your system well, to be sure that you will know about the problem sooner than your boss. And you don't have them, like many of them. Yes, so just like the key points here is that If you don't know what to monitor, check with your boss or find out what was your last outage. Hope you don't have outages. Don't pick many. Try to have them short, clean. So you need to unfortunately clean it, and just keep it simple. So that's the basic. And if we understand the use case, we know how to go to build it. And at the same time, I try to explain you why, in the first place, you need to monitor in a Canary monitoring, because that will be you who is called by the angry boss. Yes, so it's better to fix it before. And going to how to build it, it is a little bit more problem or complex. And maybe I will not. That's the same. I will not give you the magic tool. That's the. And there's no, in fact, I don't believe that there's a magic tool inside. I will give you just the main things that you need to consider or need to watch out for. Yes, so the first thing is that you need to have monitoring at least as reliable as your system. And that's the stack that we are using. Pick your own stack. It works for us for many reasons. I believe quite well in, let's say, the work that Amazon is doing, so I'm not that much afraid of using that. In terms of the monitoring, we use the Grafana, we use alerting. So the whole process is, from my point of view, reliable enough, and I don't need to monitor my monitoring system, and don't need to be afraid of that. Yes? So that's the first thing. The second thing, which you can think of taking some shortcuts here, but really don't, is you need to be at the same site as your customers. So if customer is using internet, use the same internet. Don't try to do that from the data center inside. You will not monitor firewalls, you will not monitor NAT gateways, switches, ISPs, routers, and your application. Or you might monitor your application, but you will lose quite a significant part of your stuff that you have. And from my experience, bad luck does not choose. It's not that your application will break. It's anything can break. And usually when it breaks, for the second time, it's different thing that it for the first time, unless you don't basically fix the things or don't do root cause analysis, and you have the same problem all over again, and you are fixing every week the same, like Apache server that is wrong, or application that has out of memory or whatever. And I have seen all of the things failing, and the idea with Canary monitoring is that whatever will break, so like a bird, we don't care. We don't really care on that part what will break. We need to know that it breaks. And then it's just for monitoring, but there is an architecture inside how you develop your monitoring stuff. And this architecture needs to be in place, because later you will want to extend this monitoring. You will want to cover new products, new services, and it will become a nightmare to develop it if you just do one single big file, because it's simple use case, I can do that, but then later you want to extend, you don't have how to do that, or you make up with a lot of mess inside the code. So infrastructure you will not put into the single file, so that's easy. But make sure that the library is like crypto stuff, some decoding stuff that you have, you need to do, because like you have found out that the payloads need to be somehow not the JSON but anything else, and so on. Build a client API layer, which is very important because you are from outside, so the API needs to be separate part. Then scenarios, because you might shuffle. So if you want to do like on the e-commerce site, you want to do a checkout process, so you need to log in at some point, and then later you might think about, okay, I need to log into the cancel, so there will be two scenarios, and so on. And then the next part is runtime for monitoring, and just at the very top, there's nice additions that like stability, performance, load testing that is still on the same stack that you built. I will show you how to do that later a little bit, but just make sure that you have a proper layers. Yes, it can be simple, but layers need to be in place. And then let's have it done. I would recommend use, so first of all, if you have a simple use case of website, maybe there are some services available, but like when you have an API that is custom with encryption, with stuff that needs to be propagated from one call to the other, just use Python. Why? Because this is scripting language. It's linear, so in the same way, it follows the use case from one step to the other. It's easy. It's easy. If like you are developers, even Java developers, you should be able to write a simple Python code. It has library for everything. That's the good thing and bad thing. But with the code that is simple, I don't care that much if they will change requests or if I find out that in Python there's a new super request library for REST APIs and they will drop the old one, I will just like drop it and change it. If you have a layers, it should be easy. And then there are next advantages, yes? So this is lightweight. You don't want to run JVM each time to once a day or every 5 minutes to test your application because it will be more like problematic to just run those tests than just do a test. And it is supported by AWS Lambda and many more, so it should be easy for you. And then it's the last part of how you should do that. I don't want to like debate about Git flow or other frameworks for the development, but just to be sure that you have some processes around the development that you follow also for the Canary tests. So if you are a SRE or DevOps building this Canary stuff, then ask colleagues from the development what they are using, how to do that properly. Yes? So how they do it, what are the practices within the company, what are the good practices to do that you follow. It's not production code, but it is professional code. So it cannot be done like a home project or pet project. It needs to be done in a professional way. So you can extend it, you can work with that in the future, and you can debug that in the future as well. So you will find the problems as well, or the API will change, and you can also change your Canary monitoring API. So just like quickly, the most important points is like you need to be reliable with your monitoring, you need to be external, you need to have the proper architecture, and then like development practices, and use something that is simple. If you want to use something else, maybe you have the use case, but I really would prefer either use Python or even simpler things like Bash or whatever you think it's enough to do that job. And now when I was doing research about the Canary monitoring, about like how Canaries were used in the old days, I found this picture and found out that in Great War, the soldiers were using Canary birds also in tunnels to find out about the poison gas that enemy want to put into the tunnel to kill basically the whole brigade or whoever is inside. So that's like the fun fact. And here on this photo, I need to be honest with you. It's not soldiers prepare Canary birds to the tunnels. It's British soldiers, in fact, saving these birds from unoccupied village and taking them and feeding. So this is not the birds that will die. Yes, and war is evil. Okay, and that's like the second part. So you know why you want to do that, you know how to do that, and then there are the things that you need to be careful about. And maybe the first thing is that you will not know with Canary monitoring, like with a Canary bird in the mine, what was the reason that it failed. And you will not know which part of the system fails. So as you can see on this diagram, some systems might be quite complex. I hope it's not your situation, but in fact, it is not just like simple web server. It's just more it's more complicated scenarios, and usually to find out where exactly the problem is takes some time. The mitigation strategy for that can be to check basically how the different part of the system, like when you put your database down, how it reacts with Canary monitoring. So you will be able to better understand based on which scenarios fails at each step, like what is place that you should look for the problems for. And I am a big advocate of Canary monitoring, but I'm not a big advocate of not having different monitoring at the same time. So you should have many different monitoring levels to be able to quickly find out the problem and fix it. And second challenge for that is that the Canary monitoring will detect the situation only after it happens. So if we have the e-commerce website, maybe we can afford to do this scenario every like 5 minutes, but then it is for the worst scenario will be 5 minutes before it goes down that your monitoring will detect it. Then I'm a SRE and I don't want to most probably be waking up in the 2 a.m. just because one prop failed. So I will add at least one more. So to be sure that 2 props fail, then it's already 10 minutes. And then I will also think like maybe one more. Yes, it's 2 a.m. So maybe 15 minutes of downtime at 2 a.m. is not a big deal. Yes, so that's some time that it requires. And that's the use case that we can monitor pretty in real time. So I would say 5 minutes, each 5 minutes is a pretty runtime. But there are some use cases, like if you are, for example, SaaS provider for the multi-tenant solution of a commerce site, then you don't run the full use case every 5 minutes to creating the new tenant, because this will be overkill. Yes? So you will run this use case maybe once a day or once a week. Still, it will be better because once a day, or at least a day after, you will understand that the system with the automatic creation of multi-tenant will not work, but you will not have this run like in real time. Yes? So that's you need to consider what is the worst case scenario and what you can afford as a pause between basically your system running and detecting it by that. And again, you can, as on the graph here, just by noting not only the result of the test, but also time it takes on each step by increasing. So usually when something breaks on the system, there is a first sign that something slowed down, some steps. So here you can see that we have some strange looking peaks at the first graph, and you can just checking which step it is. So this is like start transaction, post document, verify document, get results. On verified documents, you can already see that something is wrong, but when you just zoom into get results, you immediately see that there's a big problem in the system and you can fix it before it will go down. But it's not always such a scenario. So it is just a mitigation strategy. And then, like, there's problems or challenges, but everything has two ends. So there's also the benefits. And first benefit is a little bit debatable from your direct development point of view, as this really gives you the ground truth of the state of the system. So if you do a deployment of the new application and something goes wrong, the rolling update will not work like it should. There will be some change in the configuration that basically prevent correctly start of the application. That will be noted by the monitoring system, and later, of course, when it is a situation, SRE will try to fix it, but afterwards, like several hours later, we can basically check exactly how much time we have a downtime and get back to you, like asking why it just happened in the production. The deployment cost like 20 or half an hour of outage, and then like we use SLO, so you will probably not be able to upgrade your system again in next 2 weeks or 3 weeks, depending how much we spend on the SLO budget. Then Of course, having just monitoring, automated monitoring in the first place is a good thing, but as a SRE, I also want to have some way of checking it myself. So it gives you the CLI. If you run properly the architecture of your Canary monitoring, you can just execute the Python script, and then you will get the results of how it goes. And when it is deployment, I can just execute it, and immediately after 12 seconds, I know that the main use cases, that the most important one, are working fine, and I can close the deployment, do some other stuff. I don't have to wait for the monitoring. I don't have to check it myself. And also, when somebody will come to me that the system is not working, I can use this immediately to find out, okay, this is the step that it breaks, and try to see what the result myself, go into the code, maybe try to see with Cal or different things what's going on. The next thing that you will get when you do it in a proper way is the performance test based on your real use cases, on most important use cases. So you will be able, with like additional libraries that are available, to run the same scenario, not like once a 5 minute, but 10 requests per second, or like 5 parallel use cases in the same time. Yes? So you will be able to do this performance test before you deploy. Of course, when you develop applications, you run performance tests on the end of the build pipeline or release process. But just in case you don't, that's the tool that SRE should have to help you on that part, also to check it. And then there was yesterday discussion about how you should run properly the performance test and not over expect the let's say speed of your application, but it's also good to see how it breaks. So if I have a tool like that, I can do a flat test and see, okay, I will try to do 10 times more than you expect, or 100 times more, and see how it crashes, or if it crashes, how it recovers from the service, or if it recovers from the service. So that's the things that we can do before we deploy to make sure that it's exactly what you basically want to have in production. And then still on the performance topics, when you note down minute after minute the time that transaction took, you can detect things like that. So we have a new version of application that was deployed. It requires machine learning processing, so the time is heavy here. And the new version just suddenly doubled the time. So from 2 seconds, it goes to almost 4 seconds. And then we say, okay, but we didn't expect it, so we can go to you, to the product owner, and say, ask what is the situation, yes, if it was something that we should be worried about or that is normal. So in this case, they prepare a much more detailed algorithm to analyze the data that was much heavier, and the time spent was used to have a better quality of the algorithm. So it was the expected behavior, just that it was not communicated to us ahead of time. The benefits there are many benefits of the Canary monitoring, and I already want that you are overwhelmed with all of that benefits, and you will get back to the work, and then you will think, how can I develop it on myself? And then the next one is about, it's very also interesting one, so the non-deterministic and hidden issues. In fact, there should be 2 benefits, but let's not be that much. So not deterministic. You of course know that, like when you do tests, that sometimes it fails, not always, but every second request or every 10 requests. But do you know if it fails 1% or promille of the requests, so 1 in 10,000 of requests, or 1 in 10,000 of requests, the use case might fail because of something that will happen in your application? I will know about it with this Canary monitoring after maybe a day or 2 days, and I will investigate what was the situation that on Monday 11 it fails, and so on. And at the same time, hidden issues are also something that is very hard to test otherwise. So if you write your logic of application that you base it on some log, for example, processing that you do over the night, and logs are rotated every night, Are you sure that the exact moment of lock rotation, everything also goes fine? Or did you check your application when time changes from summertime to wintertime? And then there's nothing lost with the processing and everything goes. Yes. So if we don't such a tool, somebody will need to test at the moment. Yes. Or make sure that it is done like that. And this is the last one. So if it is external, if it is done from some different place than your data center, so you can monitor multiple environments with the same thing without any additional effort on to do that. So you can monitor development environments, you can monitor staging environments, production in different regions, maybe some on-prem customers, and so on. Yes? So, and not only you can monitor, but also you can check performance on the different environments, how it behaves over time, and if one environment is better than the other, or has some problem that was not on the other. So it's basically all the things that you get without like doing anything more than just having the properly set up the Canary monitoring system. And like key takeaway of that is first, it's really easy to implement. So don't be scared, especially by the developers, that they will say, okay, our client API and our use cases are so complicated that nobody can integrate over that. It's not true, because then customers will not be able to use that API in the first place. And if it is true, then they should think about how they implement the API. So it's easy to implement. It is a Swiss Army knife for you. So it has many possibilities. In fact, you just need to realize that by using that it is only a Swiss Army knife. So if you want to have a proper performance testing, don't use this only tool. Use something that is designed and built and like properly in proper situations. You monitor all the things like CPU of the worker nodes and so on. And this is the small thing. So you will not normally use this tool to, basically like the scissors from this tool to run the textile factory. Yes, you will have some proper ones, or like screwdriver to fix a car. Yes, it's still Swiss Army knife. Yes, on that. And the Canary monitoring, in my opinion, is the best value for money or for effort. You cannot invest building any kind different of monitoring to get so much out of it, like in that fast time. So if you want to monitor, for example, memory of your applications, it requires similar effort, and you will just know about memory of the applications. It does not mean that it is the only way you should spend effort to monitor, of course. So that's the first, I would say, effort that you should use to spend on monitoring. And I think that's the time for the questions, if there are any. If not, I have prepared myself one, too. So the question is, do you consider using BI and its trends to understand if there is a business issue instead of synthetic transaction and cleaning load? So that's in fact a good question. Yes, but then I think I will not use in the Canary monitoring in the first place, because I would like to have more data of what's going on. So I would put some probes into the system, inside the system more than outside. And I think it's the point of Canary monitoring is to keep it as simple as possible, and at the same time that it will give you enough information and enough possibilities to monitor properly. So if you have some additional questions, or if you want to see how we run it in production, you can approach me or ask it or find me anywhere else. And I think it's done, so thank you.